All right, in example 7, we have an inverted cone leaking water at a rate of 1 cubic centimeter per minute. The cone has a height of 9 centimeters and a diameter of 6 centimeters. Find the rate at which the water level is dropping when h equals 3 centimeters. And they've given me the volume formula for a cone, which is 1/3 pi r squared times h. Let me go ahead and write that down. That's what I know. It's already written for me, but that's okay. And they've given me some information here. They have told me that the change in volume is 1 centimeter cubed per minute, and it's leaking water. So that means that dV dt is equal to a -1 cubic centimeters per. Lastly, they have asked me to find the rate at which the water level is dropping. Now, if you think about this, what's going on is I have a change in height of the water level. And so that means we're going to be looking for the dH dt. And they have told me to find that when h is equal to 3 centimeters. Now let's take a minute and think about the cone. They've given me a lot of information here. They've told me that the cone is 9 centimeters in height, and so that translates over to my right triangle here as overall height of 9 centimeters. They tell me the diameter of the cone is 6 centimeters, so diameter is all the way across. That means the radius is going to be 3 centimeters. And as we have pointed out, we have a water level inside that cone that has its own smaller radius and its own smaller height. But what is awesome about this is that these two are similar triangles. So I can set up a ratio to relate height and radius. So here we have 9 over 3 is equal to h over r, and of course 9 over 3 is equal to 3, so I have h over r equals 3. So I noticed this, and I think that this will help me greatly simplify the calculus in this problem, because now when I take the derivative of v, I don't have to use the product rule and differentiate r squared and h. Because now I can actually use this relationship to substitute in and just have one variable to take the derivative of, and I'm all about that. The idea is that for the height of the water, there is always a corresponding relationship for the radius given by this equation, h over r equals 3. So you know what, since the r is being squared, why don't we solve this thing for r and then substitute in terms of h. So if I do that, I am going to get r equals h over 3. So now let's do our differentiation, but let's start with this equation. V equals 1/3 pi. And instead of r squared, I'm going to substitute in place of r, h over 3. H over 3, and that gets squared, but then it gets multiplied by another h. All right, so let's see. So this gives us 1/3 pi h squared over 9 times h. And that's going to simplify to pi over 27 h cubed h squared times h. So now I can differentiate. So dV dt is equal to pi over 27, and differentiating h, we have 3h squared by the power rule, so put the 3 out front, times h squared, and then by the chain rule we have dh dt. All right, let's see if we can clean this up a little bit. 3 goes into 27 9 times, and so this gives me now dV dt is equal to pi over 9 h squared dH dt. Now they told me that dV dt was -1. So let me do my substitution step. So we have -1 in place of dV dt is equal to pi over 9 h squared. Now h is going to be equal to 3. So that's times 3 squared times dH dt. Well, 3 squared is 9. 9 cancels with 9. And if I solve for dH dt at h equals 3 is equal to -1 over pi centimeters per minute. And that concludes lesson 3.1.